this, the Ohio River. Pleasant, beautiful river which rolls through the Middle West and merges with the Mississippi to flow majestically into the Southland. The river here at Cheshire in southern Ohio is already broadening. Often muddy, sometimes good fishing. The catfish are biting now, and on the banks the always hopeful fishermen know it. The country here is friendly, and so are the people. I know them both. I've lived here most of my life. My name's Fred Carmen. This is my home. And this is my wife, Maxine. And the... My mother still lives nearby, above the river. And I don't think she'd move away from here and the river for anything. I can understand that. It takes hold of you, the river. Why, I remember playing right here like my boys are. And like I hope they do, I dreamed along here too. I often looked out across the river from my bedroom window and thought about the future. But I never dreamed then, nor when I was away learning engineering, what would happen right here or of my part in it. For what happened is this. That's the Kiger Creek Power Plant. It's right next door. And surprisingly enough, I worked on this plant as its construction engineer. I was back home, but this time as one of a team of thousands of trained men from all over the country. It was a job that went beyond the boyhood dreams of any of us. For this power plant and its twin, the Clifty Creek plant, some 200 miles downriver at Madison in Indiana, are the largest in the valley, two of the largest in the world, and were a very special project important to free people everywhere. They supply the enormous amounts of electric power needed to produce atomic material for defense and peace. Everyone and everything was important on a job like this. Cooperation, teamwork, and what, for want of a better word, we call know-how. That was really the story on this big assignment. Nearly $400 million big, the price of 8 atomic submarines like the Nautilus. So big that some people thought it could only be done by the government. Those people were wrong, though. The job was done by 15 electric companies who got together and tackled it on their own. It was teamwork and know-how that built them. Teamwork of the men, know-how of these companies which were willing to take the considerable risk. How did it all happen? That story starts back in 1952.
Washington, D.C. in early 1952 was the capital of a nation engaged in 2 wars, a Cold War and a hot one in Korea. From high levels came the decision that an increased stockpile of atomic weapons was needed for national defense. This was the job of the Atomic Energy Commission. The AEC moved quickly. The primary need was a new plant where the element U-235 would be refined in greater quantities. The Atomic Energy Commission favored the location of a $1 billion uranium diffusion plant somewhere in the Ohio River Valley. Its first problem, how to obtain the enormous amount of electric power needed by such a plant, almost twice as much power as then used by the whole state of Indiana. Nowhere was such a source of electric power available. Without it, there could be no increased atomic stockpile. A call went out from Washington for help. Soon, a group of electric utility companies serving the Ohio Valley area sent men to Washington for conferences and studies with the AEC. Could they provide this largest single block of power in the history of the industry? Could they provide power in a hurry, some almost immediately? Could the private companies build and maintain such a gigantic power plant or plants needed to do this? Could they provide low-cost power around the clock and around the calendar, but be ready to discontinue it at any time and permanently if the AEC so decided? Recognizing the emergency and their nation's need, their answer was yes. Thousands of other important decisions followed. The AEC pinpointed the location of its plant along the Scioto River, midway between Portsmouth and Chillicothe in southern Ohio, and called it the Portsmouth Project. Hundreds of people in the fields of engineering, construction, finance, and legal matters went to work, and one by one, The questions were answered and detailed estimates drawn up for the commission to study. From the home offices of each of the 15 companies came help and suggestions to make the power project's operation low in cost, high in efficiency. To begin with, it was estimated $440 million might be needed to finance the power project. No small hurdle itself. The reputations of the 15 companies and their customer helped, though. And within the briefest possible time, the financing was supplied by insurance companies and banks and by the sponsors themselves, and without any government funds. And to produce such power, steam-generated electric power, two natural ingredients are necessary, and the nearer the better. The first is water, vast amounts of water. The Ohio River solved that one. The second is coal. This could be delivered at low cost from West Virginia and Ohio, from Kentucky and Indiana. Some $30 million worth of it a year would be needed to produce so much electricity. To be close to the coal fields and yet not too far from the atomic project, the 15 private electric companies proposed to build two power plants rather than a single plant. One, the Clifty Creek plant, to be located at Madison, Indiana. The other, the Kiger Creek plant, to be built at Cheshire, Ohio. The two instead of one plan was dictated by other reasons, too. For security, two plants would be less vulnerable to enemy attack or floods than one. And for speed, two would be faster built than one larger plant. The lights in drafting rooms and engineering departments burned far into many nights. In October 1952, a contract was signed by the Atomic Energy Commission and the newly formed Ohio Valley Electric Corporation, or OVEC. Temporary headquarters was soon set up near the future atomic plant. But even before the power plants could be built, the AEC needed huge amounts of electricity. The 15 companies were soon supplying this interim power directly to the AEC Portsmouth project for construction. On December 4th, 1952, after months of constant pressure, checking and rechecking, meeting and re-meeting, and yes, sweating too, work got underway at the sites. A crowd like that at a plowing contest at a state fair watched the governor of Ohio hop into an earth mover, turn the throttle, and break ground for the largest private power project the valley or the world had ever seen.
And some plowing contest it turned out to be. We figured we'd dump dirt enough to fill a ditch 6 feet deep from New York City to Salt Lake City, and then some. And then to set down a solid base for the foundations, we brought sand and gravel, spread it out in layers with bulldozers, and packed it down hard. There was teamwork and construction, too, right from the start. Like this, one fellow gives another a push. Up and over. Every step of the way was checked and double-checked, like examining our foundation, the backfill, which I did here, and which Earl Snodgrass was doing at Clifty. Earl was Clifty's construction engineer, sort of my twin, and a friend, too. On these jobs, there was a friendly rivalry to get the jobs done right and ahead of schedule. And every step was talked over with the engineers and technicians. The engineers to make the plans, the technicians to put them in motion. Every day counted. We were up against a rough schedule. Snodgrass crew at Clifty and ours at Kiger, with first power due for delivery from the new plants in 2 years. It takes that long just to build a house sometimes. But I think we all knew that the schedule makers meant it. Every job counted, too, with some 6,000 skilled construction men coming from all over the United States to work together. From the east and the west, from the north and the south. Material had to be ordered as much as 2 years in advance, so it would arrive when we needed it. Try patting the top of your head with one hand, rubbing your stomach with the other, and dancing a jig, and you'll get some idea of the job of synchronizing the incoming shipments. Luckily, the ingredients for concrete, our first real need, came right from the neighborhood. But the ingredients went into the mixer by special recipes, different mixtures for different parts of the buildings. These recipes had to be followed exactly, with no failures allowed, like a bride's first cake. Before pouring the concrete, forms had to be set in place. Then steel reinforcements welded together to strengthen the concrete. And soon the results began to show. Men from Michigan and Kansas, steel from Pittsburgh and St. Louis building plants in Indiana and Ohio. To build a plant to produce electric power takes machine power, plenty of it. But more important, skilled manpower, the power of men trained in our schools, and men who picked up something on the local ball field, too. Nice handwork. And footwork. And sometimes a good kick works wonders. We always kept one eye on the weather, especially winter weather. Freezing temperatures meant concrete trouble, unless we got the mix to the forms before it hardened. So we heated the mix and used power wheelbarrows, which scurried back and forth and prevented the concrete from turning into frozen pudding. It got dark early now, but the work went on. We were starting on the stacks. They had taken a lot of research and planning. Engineers, scientists, and weathermen had worked together to decide how high the stack should go to dissipate the smoke into the atmosphere. And then the stacks rose, and rose, and rose. We were going to new heights, all right. Clifty's 3 stacks to be the tallest in the world, each over 100 feet higher than the Washington Monument. Some transmission towers had to be way up there, too, as high as 200 feet, to carry the power lines to the atomic plant. Nearly 800 miles of high-voltage lines were strung. Porcelain insulators, wiped clean, hold the lines up there and well away from the tower so the current won't jump over and hightail it down to the ground. Stringing lines isn't child's play either. It takes alertness and care. Every action means something. A nick or a scratch in these almost 2-inch thick lines can mean trouble. So we kept the lines off the ground. And every splice of the cable, which we had to make about every quarter mile, can mean escaping power unless done exactly right. It's tough work and hot, but once in a while you get a break. Some 4 towers every mile, soon to carry the highest voltage lines in use in our country. Meanwhile, work on the plants went on as scheduled, month after month. Now by bricklayers, now by welders, now by roofers, now by insulators. Every bolt tightened at the right time in the right place. Every detail watched, from the smallest rivet to the largest railroad car in the world, on our own private railroad line. Finally, the first of the stacks was complete, a monumental landmark of concrete and steel. Up he goes. There wouldn't be any electric power, however, without the fuel and water. Coal, brought by several of the area's major coal companies. Water, millions of gallons each day, pass through the plant to condense the steam, then return to the river. Just like we had our own railroad gang, we also have our own Navy. Well, that is a tugboat, a captain, and his crew to dock the coal barges. It took over a year to unload coal to fill up the two stockpiles, each with more than 1 million tons. If you can't visualize 1 million, here's 56,000 tons of coal waiting to be unloaded. The coal reserve is over 3 months' emergency supply, which would move into the plants if needed, with new shipments filling the gap in the pile. And the boilers, 11 of them, were being erected. Each boiler tall as an 11-story building and blacker inside than coal. Every one lined with some 150 miles of tubing for water. The heat in the boiler turns the water to steam, and the steam is piped into the turbines at 1,050 degrees and with 2,000 pounds pressure. You can bet there wasn't any guesswork in setting the turbines in place just right. Easy does it. The same went for the generators, which actually produce the electricity. You see, the steam makes the turbines move. The turbines make the generators move, and the generators make the electricity to make the atomic plant move. Mighty important fellow, the generator. And, of course, we have to check our fuses, too. Biggest ones you ever saw. We call them circuit breakers. You can't store electric power. It has to be generated when you need it. So you need a nerve center with meters, levers, and push buttons. That's the control room, one for each of the 11 units, connected by thousands of miles of colored wires to the boiler, turbine, and generator, and of course to OVEC headquarters. Once set up, the controls would be hard for an enemy to knock out because they are right in the bases of the stacks and are bomb-proof. And then, on February 15th, 1955, the first units at Kiger and Clifty went on the line. The first smoke. The first fly ash sluiced out. The first generator reaching its rated capacity. Just one generator out of the 11, yet turning out electricity enough to supply every home in a city of 1 million people. That's power. We were now really on the beam. The growing plants kept beating the original deadlines by more and more time. Clifty Unit 3, completed July instead of August 55. Kiger Unit 4, completed November 55 instead of January 56. Clifty Unit 5, November 55 instead of February 56. And as Kiger and Clifty approached full capacity, the sponsor companies were called upon to supply less and less of the interim power. They took up their permanent role as backstoppers, reservoirs of power in case of emergency. Electricity at 330,000 volts, highest in our nation, was now humming over the countryside. West from Kiger, east from Clifty, to OVEC headquarters, where, in another bomb-proof control room, man and meters regulate the load from Clifty and Kiger, a load which must keep coming into the Portsmouth project 24 hours a day. And beyond, past the final switch yard, is the destination, a steaming giant, the Portsmouth Uranium Diffusion Plant, 210 acres of floor area, 4 years to build, using nearly 2 million kilowatts continuously, dedicated to the peaceful use of the atom and the defense of the nation. Sure, all of us were proud of our twins, and we were especially proud on Dedication Day in May 1956. Earl Snodgrass, my twin on the OVEC project, was over from Clifty, where they'd had their dedication the day before. My wife and boys were there too, and met my boss out from New York. I can tell you I felt a little out of place with all this excitement, sitting near governors, congressmen, top industrialists, and representatives from the Atomic Energy Commission. They unveiled a plaque and then told about our plants. The plants that some people said were too big to be built by private electric companies. Yet, as the speaker said, they were built, and by free enterprise with investors' money. In fact, they pay money to local, state, and federal, more than $2 million annually in taxes. And what else did they say? Well, OVEC had outstripped all its commitments to the Atomic Energy Commission. The plants were finished 9 unit months ahead of schedule. This alone lopped some $3 million from the AEC's first annual electric bill. At the time of completion, they were capable of producing 165,000 more kilowatts than originally expected because of design improvements during construction. They're the world's most efficient power plants, too. And in spite of rising costs during construction, the unit cost of power to the Atomic Energy Commission is less than originally estimated, a savings of more than $500,000 annually. These plants were called symbols of the challenge which free men can meet. The real story behind it all, the main speaker said, was the cooperation of the 15 electric companies who teamed up to meet this challenge. No one of them could have done it alone, but 15, working together as one for America, did do it. And you know, I was so close to this that I'd hardly seen the whole picture until now. But it's true, all right. And maybe what was done here will help remind our children what can be done in this country by people who are free to think and dream and accept challenges and make the impossible come true.